All right, let's take a look at combining functions here for 2.8. All right, this first part is just some notation. Okay, we've got two functions, say f of x and g of x, with the same domains. That part's actually kind of important. Okay, with the same domains, we can say the following. If we want to add two functions together, this notation, f plus g of x, well, all that means is I'm going to take f of x and add it to g of x. Okay, same thing with subtraction. This notation, f minus g of x, just means I'm going to take f of x and then subtract g of x. Same thing with multiplication. Right? F times g of x just means I'm going to take f of x times g of x. And for division, if I've got f over g of x, that means f of x divided by g of x. When we're dividing, though, we have to be careful, okay, and talk about the domain. So remember, whenever we have anything in the denominator of a function, we have to talk about that cannot equal 0. All right, so we'll revisit domain a little bit in this section, okay, looking for where a denominator cannot be 0. All right, so let's take a look at a couple of examples for this real quick. So we're given two functions here. F of x is 2x squared minus 7x plus 3, and g of x is 4x plus 1. So the first function just tells me to find f plus g of x. Well, remember, that's the same as f of x plus g of x. All right, so I'm going to take 2x squared minus 7x plus 3 and add 4x plus 1. So I'm just combining like terms here. Right? So I guess I should be putting equal signs here. So 2x squared, there's nothing to combine that with. So we just have 2x squared. Then negative 7x plus 4x would be negative 3x. And 3 plus 1 gets me 4. So when we are combining functions like this, especially with addition and subtraction, it's important to use parentheses, right? And we'll see why that's so important next when we look at subtraction, right? So put parentheses around each function as we substitute them in, right? So I substitute this in place of f and this in place of g. So let's try subtraction here. All right, so again, this is the same thing as f of x minus g of x. All right, so I'm going to say 2x squared minus 7x plus 3 minus 4x plus 1. So now again, we're combining like terms, but this time I've got a subtraction sign in between these functions. So 2x squared, there's nothing to combine that with. But now I've got negative 7x minus 4x. That's going to get me negative 11x, and 3 minus 1 will be positive 2. Okay, so it's important to make sure that we use parentheses so that we see that that negative sign ends up getting distributed to every piece in the second function. All right, so the third example, we're just dividing these functions. So I'm going to take f of x divided by g of x. So that's going to be 2x squared minus 7x plus 3 all over 4x plus 1. All right, so we could try to simplify this a little bit. I think the numerator does factor here, but I don't think anything would end up canceling out. What we do want to look at, though, is any domain restrictions. Whenever we have a denominator, we want to say what x cannot equal. So in this case, we have a denominator of 4x plus 1. So remember, that's where we said, well, whatever's in the denominator cannot equal 0. So I would just solve this, subtract the 1 over. So 4x can't be negative 1. Then divide by 4 and say x cannot equal negative 1/4. So when we get an answer here, we want to also express the domain restriction. So we say x cannot be negative 1/4 in this answer. Okay. So we can also do this by plugging in values, right? So what this means, right, if we have a number here instead of an x, this is saying take g of -1 over f of -1. Okay, well, I'm just going to plug -1 into these functions then. So g of -1 would be 4 times -1 plus 1, and f of -1 is going to be 2 times -1 squared minus 7 times -1 plus 3. So we can do some arithmetic. 4 times -1 is -4, plus 1 would be -3, over -1 squared would be 1 times 2 is 2, plus 7, since I've got the double negative, would be 9, plus 3 is 12. So -3 over 12 would reduce to -1/4. Right? So if we have a number here, all we're doing is plugging that into the functions. All right. So why don't you guys try this one? Okay. Evaluate f of x, or f of 3 times g of 3. All right. So again, this just means f of 3 times g of 3. Right. So I'm plugging 3 into f. So that's going to be 2 times 3 squared minus 7 times 3 plus 3 times g of 3, which would just be 4 times 3 plus 1. So what do we get in here? That's 9 times 2 is 18, minus 21 would be -3 plus 3. We actually get 0 for this first part, times 13, but 0 times 13 is just 0. So f times g of 3 is 0. All right? You guys go ahead and try this next one as well. All right, so again, this means g of -2 minus f of -2. So I'm plugging -2 into g, so 4 times -2 plus 1 minus 2 times -2 squared minus 7 times -2 plus 3. So just do the arithmetic. 4 times -2 is -8, plus 1 would be -7, minus -2 squared is 4, times 2 is 8, plus 14 would be 22, plus 3 gets me 25. So -7 minus 25 would be -32. All right. Next, let's take a look at compositions of functions on the back of your sheet there. So this is just plugging one function in for another. The notation for that, okay, is f and then this little O looking thing, f o g of x, right? If I've got two functions, f of x and g of x, and I want to compose them, f o g of x. What that means is I'm plugging an entire function in place of x, okay? Now, one thing to be cautious of, okay, is this idea right here, all right? We need to make sure that the range of the inside function must be within the domain of the outside function. Now that's not going to creep up too often. Okay, that's only going to creep up whenever we have domain and range restrictions. Right? Most of the time we don't have those. Okay, but we need to be careful of that. So let's take a look at what this actually looks like. All right, so in this we're given two functions. Here's f, here's g. So f o g of x means f of g of x. That means I'm going to take x plus 3 and plug it in place of x everywhere in f. So this will look like 2 times x plus 3 squared minus 4 times x plus 3. Now we can just simplify. So I want to square this first. Right? So again, remember, we cannot just distribute that exponent. Remember, x plus 3 squared means x plus 3 times x plus 3. Right? So we could FOIL this out, right? Or if you remember the shortcut, okay, the shortcut, square the first, take 2 times the product of the 2, so x times 3 times 2 would be 6x, then square the last is 9. But if you don't remember that, you can go ahead and FOIL this out, right? So if we FOIL out, we get x squared plus 3x plus 3x plus 9, which would simplify to x squared plus 6x plus 9, all right? And minus 4 times x plus 3. Then distribute these, so 2x squared plus 12x plus 18, and then distribute this negative 4, so minus 4x minus 12, and finally combine like terms. So we'll get 2x squared plus 12x minus 4x would be plus 8x, and plus 18 minus 12 would be plus 6. So our composition of these two functions ends up working out to be 2x squared plus 8x plus 6. All right? There would not be any domain restrictions because the domain of both of these functions is everything, right? Negative infinity to positive infinity. All right? So we can actually also compose a function with itself. So f of x means take this function and plug it in place of x everywhere you see an x, right? So this means f of x. So why don't you guys take a minute and try that one, okay? See if you can compose f of x. All right, so I'm plugging f in everywhere I see an x in f. So that's going to look like this. Minus 4x squared, right? This was plugged in place of x here, and then it'll be plugged in place of x here. So we just want to simplify this. So squaring this could get a little bit ugly, right? If you want to write it off to the side and say 2x squared minus 4x times 2x squared minus 4x, you can definitely do that. I'll use the shortcut here though. So square the first, 2x squared squared, right, is actually going to be 4x to the 4th power, right? 2x squared times 2x squared will get me 4x to the 4th. Then 2 times the product of the 2. So if I multiply these together, I'll get negative 8x cubed. Then I need to double that. So negative 16x cubed, and then square the last. So negative 4x squared is going to get me plus 16x to the 2nd power, minus 4 times 2x squared minus 4x. Then go ahead and distribute here. So we'll get 8x to the 4th minus 16x, whoops, not minus 16, minus 32x cubed plus 32x squared. Distribute this negative 4, so minus 8x squared plus 16x. So my only like terms to combine are the squares here. So I end up with 8x to the 4th minus 32x cubed plus 24x squared plus 16x. All right, so, and again, no domain restrictions because domain of this function is negative infinity to positive infinity. All right. Now we can also plug values into compositions. So what this means is g of f of 0. Okay, so there's actually two ways to do this. We could evaluate g of f of x and then plug in 0, or we can kind of work from the inside out. I could first evaluate f of 0 and then plug that value into g. I think that way is a little bit less work, right? A little bit less time consuming, so we're going to do it that way. So I want to evaluate f of 0, right? So I'm going to actually come off to the side here and evaluate f of 0. So f of 0 is 2 times 0 squared minus 4 times 0. Well, that's just going to end up being 0, right? 0 minus 0. So f of 0 ended up working out to be 0. So I'm just going to evaluate g of 0. Okay, well, that means I'm plugging 0 in everywhere I see an x here. So that'll be 0 plus 3, which just gets me 3. Okay, so g of f of 0, evaluate f of 0 first, and then plug that into g. Okay, you guys try that here. Right, so this means f of g of 3. So evaluate g of 3 first, and then plug that value into f. All right, so come off to the side here. G of 3 is going to be 3 plus 3, so that's 6. So what I'm actually evaluating here is f of 6. So I'm plugging 6 in for these x's. So that's going to be 2 times 6 squared minus 4 times 6. So that's 36 times 2 is 72 minus 24. So what does that get me? 48. All right. And one more. Okay. You guys try this one. G of negative 14. All right. So this means g of negative 14. Oops. So I'm going to come off to the side and evaluate g of negative 14. So that's going to be negative 14 plus 3. So that's negative 11. So this g of negative 14 just becomes negative 11. So g of negative 11, we're going to plug negative 11 into g. So negative 11 plus 3 ends up getting me negative 8. All right. So pretty short lesson. All right. Since we are a little bit behind, I do want you guys to do the homework, okay, the work out of the book as well. All right. So go ahead and get started on that and send me any questions that you have.